In today's lesson, we'll be looking at volume and surface area, but not for our basic shapes, for combination shapes. These would be shapes that you do not see on your formula sheet, so we don't have specific formulas for these shapes, but we would need to work with the formulas for the basic shapes. We'll look at two examples. The first example is looking at what we call a frustum of a cone. What this really is the part that remains from a cone after we remove the tip of the cone. We'll calculate the volume for this particular shape. To do that, we do need to work with those basic shape formulas. So we'll work with the volume of the cone formula, looking at the full volume of the cone, and then to get the volume for the frustum, we would then have to subtract the volume of the tip that we can calculate. So the volume formula for a cone being pi r squared h divided by 3. We'll start with calculating the volume of the full cone. So I'm going to write that as volume full. Okay, so we have pi times the radius for the full cone being 4 as shown in the diagram, and the height, okay, let's be careful here, we don't want the height of the actual frustum, which is 6, we need the height of the full cone, so that would be the 6 for the frustum plus the 2 from the cone tip, so the height would actually be 8. Okay, so let's write that in there. And calculating that particular volume, we get 134.04. I'm not going to worry about units yet since we're not finished. We now need to calculate the volume for the tip. Okay, so same formula. So pi times the radius for the tip being 1 as shown, squaring that, and the height for the cone tip being 2 as shown. So calculating pi times 1 squared times 2 divided by 3 to give you 2.09. So our next step is to calculate the volume, okay, for the frustum by taking the full volume and from that subtracting the volume of the tip. Okay, so we had 134.04 and we're taking away 2.09. And I'm just going to round that to the nearest meter cubed. 132 meters cubed. In example 2, we're looking at half of a cylinder, and we're going to find the surface area for this half cylinder. Surface area can be a little more tricky than volume. With volume, you're looking at adding volumes, subtracting volumes, depending on the composite shape that you're looking at. But with surface area, sometimes you end up losing certain surfaces or adding on other surfaces that weren't there before when you create a composite shape. So let's take a look at this half cylinder. With the half cylinder, I can see that I have the semicircle portion for a base and another semicircle portion for a bottom base. That actually gives us a full base circle. We also have this lateral surface area, but remember we only have half of it because we've cut the cylinder in half. But by cutting the cylinder in half, we also end up with this new surface, this rectangular surface here. So we really have 3 surfaces that we need to consider. So we have a full circle and we have a half lateral surface for a cylinder, and we have a rectangle. Those are our surfaces. So the full circle, pi r squared, okay, we would have pi times the radius. We're given the diameter here being 12, so we would say that the radius is 6. We want to square that. So that's 113.1. For the half lateral surface, well, the full lateral surface would be 2 pi r h, but we only want half of that. So those 2's will cancel out. So we just need pi times radius times height. So we have pi times the radius, remember that was 6, and the height being 15. So we have 282.7. Rectangle, we would just have length times width. So we'd have 15 times 12, 180. So now we want to add up those three surfaces together. So addition with 113.1 plus 282.7 plus 180, giving us a surface area of 575.8. Dimensions were centimeters, so for surface area we would have centimeters squared.